Hello guys, welcome to my channel. So before proceeding for defining of material, I will correct my story data. There was a error in last video. So uh, this story data from first to second floor is 3 meter. This is will be 10 feet 6 inch. Okay, you can see from here also that it is having less height. So we will correct it. So I had corrected it, and then I will click on OK and OK. It got updated here. So now I will define my material. How the material are defined. So first we will go to define, and so what materials we are using is concrete and our rebar will be a steel. So I will go to the drawing, and here the grade of concrete which is used here is of M20. Okay, and the steel reinforcement is of 550D. So 550, you had you know about M20 concrete mix. This is the nominal mix, and higher grade of concrete needs design mix. Okay, so 20 is the characteristic strength of the concrete at 28 days ऑफ द कंक्रीट क्यूब. सो उससे हमारा स्ट्रेंथ रहता है, तो M20 है. और जो 550D में जो 550 है, ये हमारा यील्ड स्ट्रेंथ है रीवार का. और D स्टैंड्स फॉर डक्टाइल. इफ योर बिल्डिंग इज सिचुएटेड इन हायर earthquake zone, so ductile, these bars are preferred. Okay, so there are different grades of a steel available in the market, like 415 grade of a steel, 500 grade of a steel, 550 grade of a steel. Even some companies have now came up with 600 grade of a steel. Up to 650 they had gone, but I will use 550 grade. And then ductile series also comes, like 500D, 550D, 600D, but I will use 550D. So I will define this material in ETABS. So how these materials are chosen? I said that the grade of reinforcement which available in market you can use, but there is limitation on concrete, which grade you should use. So this is decided by IS 456. When you will go to the IS 456, this is the IS 456. Okay. So in table 5, you will see that different due to different exposure condition, the minimum grade of concrete are given. Okay. So when you will see here for mild steel, for plain concrete, there is nothing such thing defined, and for mild reinforced concrete, minimum 20, M20 grade should be used. So our building is in mild exposure zone. So what is this exposure zone? Mild, moderate, severe, very severe, extreme. You can get it from table above. Okay. So when you will go to this table 3, you will get it mild. Concrete surface protected against weather or aggressive condition except those situated in coastal area. So our structure is not in the coastal area, it is in Jharkhand. So it is not in coastal area. For moderate zone is also there, freezing and thawing. So you should select your concrete grade from this table, using this table 3 and table 5, that what grade you should use. Okay. And for higher grades up to M25, people go with nominal mix, but it is recommended to use design mix, so that the adequate strength must be achieved. So M20 will be my grade of concrete, and steel we choose according to the availability. You can choose 500D or 550D. So I will go with 500 grade of steel. So now I will go to the software, and I will define means uh, what is the grade of my steel. Okay. So this is my software. So I will go to the define section and then material properties. Here some materials are already here. You can delete it. It is available by default in the ETABS. So you can delete this material. So I will add new material, and then I will select region. First you had select the Indian region, so it is already here. Region India. According to the country it is given here. So material type, I will means define the first concrete. A standard will be Indian, and grade will be M20. Then I will click on OK. So all the properties which are here, like bed per unit volume, or for RCC it is 25, all that thing is given here. You should not have to change this material unless you are doing non-linear analysis. So all our analysis are here, linear analysis. So I will not do anything in this data. Already everything is defined. Modulus of elasticity, which is 5000 FCK, all that thing is defined by default Poisson's ratio. So I will click on OK. Now I will define my rebar material, means for reinforcement, rebar. So for rebar Indian and grade 550, grade of steel. So I will click on OK. Everything similarly, everything is here defined. Modulus of elasticity 200 into 10 to the power 3 MPa. All that thing is defined. I will click on OK, and then my materials are defined. Okay. Now I will go to the section properties for defining. So for section property, here is frame section and slab section, which we will use in our project. So frame section we will go here. There are some of the default materials available, but you can delete this material by going to delete multiple properties. You can select all and then delete. Okay. You can delete individually also, but and you can delete multiple also. One entry will be always here. You can delete this empty entry. See, must always exist. So I will means define my add my new property. So for concrete, I will use rectangular sections. So here is property name is here. So property name, first I will define my column. So column size will be C1, means 10 inch into 12 inch, means 250 mm into 12 300 mm. Material will be M20 grade of concrete, and section size will be concrete rectangular. So I will edit this as depth. Okay, section dimension depth is larger dimension will come in depth and shorter dimension will come in width. So I can 215 to 300 will be a proxy, and we can also give it as means 12 inch into 10 inch. Okay, so I will give this. Okay. So this is property modifiers. So this is used in cracked section analysis for capturing the real effect of the structures. But in this project, I will not use these modifiers. These modifiers are defined. Actually, what we do is we reduce the moment of inertia, and so that we can capture the cracked section analysis. Because we assume that in beam the concrete below the neutral axis is cracked, and also there is micro cracks in concrete due to which tensile strength is lower. Actually it has very negligible tensile strength, it doesn't have any. So we will leave it as usual. We will not currently define any modifier, and we will go to the reinforcement tab, and then we will edit. So I am designing column. So I am defining column, so it will come as column. Longitudinal bar, rebar method, I will select 550. What is my longitudinal bar? And reinforcement configuration will be rectangular. Confinement bar will be like ties, and reinforcement. There are two options, that reinforcement to be checked and to be designed. So you can, when you will select this option, reinforcement to be checked, you will have to enter all these two means option correctly. What you are providing your reinforcement in column, but I am selecting reinforcement to be designed. So it is not important for this to you to fill. Okay, but I will do it. Number of bars in longitudinal 3 direction, I will keep it as 2, and I will keep it as 3. Maximum bar size will be 16, and then confinement will be 8. I will just read it for the sake. Okay, so what will be the proper thing? So I will click on OK. My column is defined. Okay, so this is the axis, 2 axis and 3 axis. So you can select what is your major axis. According to this, 3 is my major axis. Okay, Now we will click on OK. Our first column section is defined. Okay, now I will add my beam. So my beam is having two type of sections. So first I will add B1 10 inch into 12 inch. 12 inch include slab also. Okay, so I will take it as gross 12 inch. Material is M20. Okay, section shape is rectangular. Depth will be 12 inch. Width is 10 inch. Similarly, modifiers are here. Width is 10 inch, and similarly modifiers are here. You can put your all your modifiers here, but I will leave it blank. And then I will go to the reinforcement. So here you will have to change your design type. So I had means in I am designing beam, defining beam. So it will be beam longitudinal bar 550 mm, and then cover to longitudinal rebar group centroid. So what is your cover? So this is effective cover. So what is the effective cover? That is clear cover plus size of stirrups plus half of the main bar. So I will assume 25 mm of cover, nominal cover. That you can also take from a reference from your drawing or from IS code. Here in the drawing also the covers are taken. Beam is 25 mm, column 40 mm, slabs cover is 20, and footing is 50 mm. So I will take 25 mm as cover, and plus 25 plus 8 mm will be a stirrup size, and plus assuming 16 mm, then half of the will be 8. So I will, this will be 41 mm will be my effective cover. So I will put, and I will leave it as it is because I am not doing ductile detailing, and then okay. So these are, so my beam is also defined. Now I will define my second type of beam. So I will not define my second type of beam again. I will do all that thing. Just I will, what I will do, I will add a copy of property of my B1. Okay. So just I will edit the name B2, 6 inch into 12 inch. Okay. Material will be M20, and all that thing is here, and I will edit it at the width 6 inch. Okay, so I will and these are already copy, since the properties section properties is copied, these all will be same, and I will click it as open. Okay, so and I will delete the property which is not required, so I will delete it. So these three types of beam and column will be used for analysis. Okay, let me insert my charger. My laptop is going have is on low battery. So my frame section definition is completed. So I will click on OK, and then I will define my slab section. So similarly, there are some default slab option available. I will delete this property, and one will be there, one I can delete. So I will add a new property. Okay. So S1. So my slab thickness was 120 mm. So slab of 120 mm I will enter here. So slab material will be also M20. Okay, and notional size detailing I will leave it as usual, and modeling type, this is important. Many people are confused that what I use for modeling type for slabs. So there are four options: cell thin, cell thick, membrane, and layered. So this is for layered slab, different material slab. I will not use it in this. And cell thick is for flat slab or fat slabs in or transfer slabs which we model. So in my case, there is no any fat slabs or transfer slabs, so I will leave it as usual. So there are two options, cell thin and membrane. So membrane is just like a पर्दा के जैसा होता है या बेडशीट के जैसा तुम बोल सकते हो, इसका कोई इनप्लेन स्टिफनेस नहीं होता है। तो या तो आप मेम्ब्रेन कर सकते हो डिफाइन, और सेल थिन क्या होता है कि ये इनप्लेन स्टिफनेस को लेता है, आउट ऑफ प्लेन स्टिफनेस को नहीं लेता है। तो हमारा जो रियल प्रॉपर्टी होता है स्लैब का वो सेल थिन से डिफाइन होता है। तो यहाँ हम लोग मेम्ब्रेन नहीं लेंगे, यहाँ हम लोग लेंगे सेल थिन। मेम्ब्रेन भी ले सकते हैं आप लोग, ले करके जब एनालाइज करिएगा ना तो आप इसका डिफरेंस देखिएगा कि मेम्ब्रेन से ज़्यादा फोर्सेस बीम पे आ रहा है स्लैब के द्वारा या सेल थिन के द्वारा, कि किससे। तो सेल थिन हम लोग लेंगे। तो यहाँ स्लैब के लिए सेल थिन हुआ हो गया, और टाइप slab thickness will be 120 mm. And similarly modifiers can be entered from here. For membrane these three will be filled, and for cell these six will be filled as 0.25 for strength and 0.35 for serviceability checks. Okay, so I will cover it later. For now, because this is a basic course, I am giving you a basic of what ETABS, how the things works in ETABS. Okay, so we will click on OK, and we will delete which is not property, which is not required. So it is deleted. Now click on OK. So our section properties means frame sections and all that thing is defined. Okay, beam properties and frame properties are defined. You can go here and modify answer property. You can check also. So all my beam columns and slabs are defined. Now in the next video, model I will model my geometry in ETABS. Okay then, thank you.